All right, now let's go through these practice questions to get more practice with both of these laws. So the first part here is, if possible, use the law of detachment to make a conclusion. If it is not possible to make a conclusion, tell why. So let's just do the same thing we've been doing here. We know how to find P's and Q's, so let's look at this first one and find P and Q. If a triangle is a right triangle, then the triangle has one 90-degree angle. So our P goes with if P, then Q. So I'm going to circle, let's circle that whole thing. Then Q. Now we also have triangle ABC is a right triangle. Now you can tell right away, this is the same thing that P said, right? It's telling us P is true. P is true. Looking at your notes, we know that that's what the law of detachment is. If we know that P is true, then we can say that Q is true. So since they said P is true, we can say this stuff here is true. So we can say triangle ABC has one 90-degree angle. Let's look at number 2 now. If a parallelogram has 4 congruent sides, then the parallelogram is a rhombus. So if a parallelogram has 4 congruent sides, then the parallelogram is a rhombus. So the parallelogram is a rhombus will be our Q. Now it's telling us the parallelogram has 4 congruent sides. So our job is to say, is this telling us if P is true? Yes, it is. So P is true. That means we can say the parallelogram is a rhombus. We can say Q is true. The parallelogram is a rhombus. Nice. All right, number 3. If P, then Q. So we have if X is greater than 7, if P, then the absolute value of X is greater than 7. That'll be our Q. Now this is telling us X is less than 7. Is that P? Is that telling us P is true? Is it? No, X is less than 7 is not the same thing as X is greater than 7. So this is not true. So if we don't know that P is true, we cannot say that Q is true. So we have to say we can't make a conclusion here. And I'm going to put, we don't know if P is true. Now let's look at number 4. If cats prowl, mice will scatter. If P, so cats prowl will be P, then mice will scatter, right? We know then is really in here. I know sometimes we get nervous when we don't see that then. So you can go ahead and write it in if that makes you feel better. So this will be our Q, right? Mice will scatter. Now it's telling us mice are scattering. Isn't that our Q? Mice will scatter. So that's Q. Now, if you look at your notes, which you should have up also, we know that it has to tell us P is true. This is telling us Q is true. But we can't do anything with that. But this is not the law of detachment. Or we don't know if P is true. All right, 5. If the light is flashing yellow, then you may drive with caution through the intersection. So if P, if the light is flashing yellow, then you may drive with caution through the intersection. Then you may drive with caution through the intersection. So if P, then Q. Now it's saying the light is flashing yellow. So again, is that telling us P is true? Yeah, it looks like P to me. So that would be P is true. Once we know that P is true, we can say Q is true. So we can say you can drive with caution through the intersection. All right, number 6, last one in this section. If a triangle has two congruent sides, then the triangle is isosceles. So if P, then Q. So if a triangle has two congruent sides, then the triangle is isosceles. Now it's telling us in triangle DEF, side DE is congruent to side EF. Isn't that telling us? So this one's a side, and this one's a side, and it's telling us this means congruent, right? We know that, the toothpaste symbol, as we've called it in class, that means they're congruent, right? So it's telling us the triangle has two congruent sides. That means P is true, right? That's what we're looking for to use the law of detachment. We have to find that P is true. So now we can say Q is true. So triangle DEF is isosceles. Now let's practice with law of syllogism. Same thing, if we can't make a conclusion, we have to explain why. So we have to take pre-calculus, you must first take algebra 2. Again, this is still conditional. We've had more practice with our if and then statements, right? So let's write it up here. We can also write this as if you take pre-calculus, then you must first take algebra 2. I think you guys might be more comfortable when you see it that way. Now you know this is your P, and your Q is you must take algebra 2 first. So P and Q. And remember, law of syllogism, we're looking for if P, then Q, and if Q, then R. So that way we can say P, if P, then R is true. So we need both of these here. So now it says to take algebra 2, you must first take algebra 1. Now I'm going to circle this to take algebra 2 because I circled it for Q already, right? Those are exactly the same thing. So that's also Q. So we have if P, then Q on our first line, and we have if Q, then you must first take algebra 1. Which we haven't seen yet, so I'm gonna underline it with the squiggles, and that's gonna be R. So on this one, you can see if Q, then R. And that's exactly what we have up here, right? So this one, we can say if P, then R, which P was if you take pre-calculus, or if you want to take pre-calculus, that probably makes more sense. If you want to take pre-calculus. If you want to take pre-calculus. Or pre-cal. Then R. So then you must first take algebra 1. So I'm going to put then you must take algebra 1 first. Either way is fine. We can change in those little words, right? Next, 8. If a tree has ragged bark, then the tree is unhealthy. So if P, if a tree has ragged bark, then Q. then the tree is unhealthy. The next one says, if a tree has ragged bark, that was our P, right? So let's give it the same underline because it's the same thing. Then the tree might be a birch tree. We haven't seen that yet here. Oop, we haven't seen that yet. So let's give that one the name R. Now we can see we have if P, then Q here. But this next line we have if P, then R. And that's not what law of syllogism is, right? Our notes told us we have to have that Q as our then and then as our if. Oh, as I erase the entire thing. So that means we can't come up with a conclusion on this one either. No conclusion. And we can't use the same P twice. I'm going to put using the same hypothesis, which is P, right? Using the same P or hypothesis is not law of syllogism. Now let's go on to this next page. Same thing, doing the same thing here, so it's the same instructions. If you like to snow ski, then you will like Colorado. So if P, you like to snow ski, then you'll like Colorado. Now it says, if you like to wakeboard, which that's neither of those, right? That's something new. Then you will like Florida. That's also something new, so let's just give it something completely different. Those are different things. Can we draw a conclusion from any of this? Well, do we have if P, then Q, and if Q, then R? We definitely don't. We have if P, then Q, and then if R, then S. Two random things, right? So that's no conclusion again here. And make sure you explain this stuff right here, this Y. So if it is Tuesday, then the cafeteria is serving meatloaf. So if P, it is Tuesday, then the cafeteria is serving meatloaf. Then Q. When the cafeteria serves meatloaf, or we think of it as your if, right? If the cafeteria is serving meatloaf. So that looks the same as this stuff we just circled, so I'm going to circle it again. Show that it's the same. Then it says Harlan brings a sack lunch. That's our new thing, so that's R. So you can see here we have on the top line if P, then Q, and then the next line that's also Q. If Q, then R. So that's our law of syllogism, right? So we can say if it is Tuesday, if P, I just spelled Tuesday wrong, yikes. Then Harlan brings a sack lunch. All right. If a polygon is a square, then it has exactly 4 congruent angles. So if P, a polygon is a square, then Q, it has exactly 4 congruent angles. Now it says if a polygon has exactly 4 congruent angles, that's the same thing we have circled, so let's circle it again so we could see they're the same. Those are both our Q, right? So far, so good. Then it is a rectangle. That's our something new. That's our R. So again, we see if P, then Q, and if Q, then R, which means we can say if P, if a polygon is a square, then it is a rectangle.